Hello everyone, let's continue with the chapter formulas and letters, and today we're going to start with quadratic formulas which are notated right here in the bullet list. And let me just go to my laser pointer as well. Right, working with quadratic formulas. What are quadratic formulas? Well, let's take a look at exercise 16. The figures below are made up of dots. If you look closely, you can see a pattern in the amount of dots per figure. Oh, is that the case? Let's see. 1, 1, 2, 3, 4, 5 plus 3 plus 1, etc. Hey, let's copy this table and fill it in. That's exercise 1, right? I already did it mentally. Figure 1 gives me 1. Figure 2 gives me 4, etc. 3 gives me 9, 4 gives me 16. Hey, what can we see right here? 1 gives me 1. 2 results in 4, and 3 in 9. 4 and 16. If you practiced previous paragraph, then maybe you will see that these are squares, right? 1 squared gives me 1. 2 squared gives me 4. 3 squares gives me 9, and 4 squared gives me 16. Then I can now calculate how much dots figure 6 has. Right, don't draw it. You can draw it. It takes a lot of time. Certainly if I'm going to ask you figure 15. Just do 6 squared. 6 times 6. That's 36. Figure 10. 10 times 10 gives me 100 dots. Right. That is actually using a quadratic formula. A quadratic formula is just a formula with a square in it. So here you can say this number in figure number 3, the number is 3 squared. In figure 8, it is 8 squared. So we could have said the figures follow the formula something squared, with something called n being the figure number. Therefore, the figure follow the formula a, the amount of dots, a, equals the figure number squared. And this again is using it in a practical way, right? A lot of the questions that you're going to do are not formulated with such a practical background, with a drawing or something. But in the beginning they do. So for example, right here the amount of dots, they already gave you the figure, or not the figure, also the figure. No, the formula, I mean. The formula equals a, the amount of dots, equals the figure number squared plus 3. Just check, for example, in figure 1, n is 1, so the amount of dots should be 1 squared, which is 1, plus 3 is 4, and indeed I count 4 dots here. If I now want to calculate the amount of dots in figure 9, remember the amount of dots in figure 9 means that n equals 9. So in this formula, change the number n into 9. We already practiced this in linear formulas, and then we didn't have a square. Now we have a square, nothing really changes except that now the number that I fill in is being squared. N is 9. That means a equals 9 squared plus 3. 9 squared plus 3. 9 squared is 81 plus 3 equals 84. If I have figure 15, then my n is 15. So copy this and change my n into 15. A equals n squared, 15 squared, plus 3. 15 squared is 225, plus 3 equals 220. 8. Okay, I think that's the end of this theory part. Okay, practice with this, and then in the next bit we're going to do this a bit more abstract instead of with practical examples like this. Good luck.